Hello and welcome to Lab 1 of the CodePath Cybersecurity University. In this video, I'm going to show you how to download and install Burp Suite and how to configure Firefox to use it as a proxy server. Also, we're going to go over how to decrypt HTTPS traffic with using Burp CA certificate. And then the second half, we're going to cover an extension for Firefox called Foxy Proxy. This will allow you to quickly switch back and forth between proxying it through Burp and not using a proxy or using your system default settings. And then lastly, we'll cover how to set up Burp and how to use the various tools within. So let's get started. If you're already on the Unit 1 Week 1 Lab tab, you can just scroll down and go to Challenge 0 and install the Burp proxy here. So I'm going to open it in a new tab actually. So I can keep that one open, and we only need the community edition. So go ahead and get community and download. And if you're on 64-bit Windows, go ahead and click download. Okay, now that it's done, we're going to open it. And on Windows, it's going to have a UAC prompt to get your permission to install it. So when you see the dark screen here, that's why. Go ahead and click yes at the prompt. And then continue. And we're just going to use the defaults, so just click next through everything. Okay, once it's finished, click on Finish. The next thing we have to do is configure Firefox to use Burp as a proxy. So go to the upper right corner on the Open menu icon and then go to Options. And from here, we'll be in the General section. Scroll all the way to the bottom. Under Network Settings, click Settings. And currently it's on Use System Proxy Settings. We're going to change this to Manual Proxy Configuration. And we're going to use a local host address, which is 127.0.0.1. The port number is going to be 8080. Also, make sure that you check this box to use the proxy for FTP and HTTPS. And also verify that this box is empty down here where it says no proxy for. Make sure that that's empty and go ahead and click OK. Next, we're going to install the Burp CA certificate. The CA certificate will allow us to read encrypted traffic. So first off, we have to start Burp in order to download the certificate. So let's get Burp started. Go to your Start menu, type Burp, and press Enter. Go ahead and click Next, Start Burp. And then from here, we're going to go up to the Proxy tab, and we're going to turn off Intercept. Intercept will stop the traffic and let you change things in real time, so it's sort of like a man-in-the-middle attack, but we're just going to leave it off, and we don't really need to use it throughout the course. So we can just leave that off, and then we're going to go back to Firefox, and now we're going to download the certificate. So open up a new tab, type in http://burp, and you should get this website. And click on CA certificate in the upper right. Go ahead and save the file. Remember the name, cacert.der. And now we're going to go back to the options in Firefox. And from here, we're going to go to the Privacy and Security section. Scroll all the way to the bottom. And click on View Certificates. And in here, we're going to click on Import. And we're going to go and import the certificate we downloaded. And we're only going to trust the CA to identify websites. We will not need to use it for email. So check that one and click OK. So now we should be able to read and change HTTPS traffic. So let's test it out. Let's try going and searching for something. DuckDuckGo.com. And let's see if it shows up in Burp now in the HTTP history tab. And looks like it's working. There's no problems. So from here, we could leave it as is, and Burp and Firefox will get along just fine. However, there's a problem now, and that is that whenever you decide to, stop doing your homework or you don't want to use Burp anymore, there's a problem because now you got to go back into the Firefox options and change this. You'd have to change it every single time that you wanted to either turn off Burp or turn it back on. Because if you just turn off Burp right now, and you go back and you think that you're just going to go back to the regular activity you do on your browser, it's not going to work. It's going to actually stall out on you, and it's going to refuse to connect. So as you can see here, it's just sitting here trying to connect to the website, and then it ultimately says the proxy server is refusing connections. So we could just go through the options and do this manually every time. Or we can make our lives easier by using an extension that quickly switches back and forth. So we're going to use an extension, and I'm going to show you how to do that with Foxy Proxy. So go ahead and change this back to your regular settings, either no proxy or use system proxy. And click OK. And now we're going to go and download Foxy Proxy. So just search for it. And you can probably get it from there, but I would get it from the addons.mozilla website, and we can get the standard or basic. Standard has a little bit more options, so we're going to go with standard. And then click on add to Firefox. And then add it. And now it should be on. So you see in the upper right corner where it says Foxy Proxy, you'll get this new icon, and click OK, I got it. And now we're going to go to the options of Foxy Proxy and add the Burp proxy server. So click on add in the upper left and give it a title. I'm going to call it Burp. And then proxy type, you can just leave as HTTP, even though it's got all these other options. If you just leave it on this one, it'll get all the traffic that goes through the port. Proxy IP address is going to be 127.0.0.1. Port number is 8080. Leave the username and password blank and click save. So now we have a proxy server configured. So right now we're not proxying any traffic, and that's why you get this icon. But let's say we wanted to proxy back through Burp. Well, we could just click on it and go to Burp. When we're done, we can click on turn off. And that's how it works. It's pretty simple that way. So let's go ahead and try to open Security Shepherd now. Oh wait, I gotta have Burp running, right? Yeah, because we're proxying, so let's go ahead and start Burp. And I'm gonna add it to my taskbar so it's easier to find. And next, start Burp. And then I'm going to go ahead and turn off intercept. So you have to do this setup every time. I'm going to turn off intercept. And then I'm going to try to go back to Security Shepherd. So I'm already logged in, so that's good. And let's see if the traffic is coming through. So let's check the HTTP history. Okay, looks good. Security Shepherd's coming in. There's a problem though, and that is that my scope is not defined. Because we're getting this website as well, and we don't actually need that. So we're going to go ahead and define our scope, because I only want the websites that are relevant to the CodePath homework. So I'm going to go over to the Target tab, and I'm going to click on Scope. And I can add each website that I want by hand, manually, or I can load from a file. So I've already created a text file called scope.txt, and it's got all the websites you'll ever need for the whole course. So you got Facebook, you got security.codepath.com, which is Security Shepherd, and you have the flags.codepath.com, which is the backend flag server For CTF and Capstone, you have wpdistillery.vm, which will be used later, as well as these IP addresses. So go ahead and put all these addresses or domains in a plain text file, save it somewhere, and I've already saved it in my documents folder. So I'm going to go ahead and load the file. And you'll get this prompt the first time. And basically what it's saying is, do you want to see out of scope items in your history? And the answer is, well, the answer is no, but answering yes will avoid accumulating the data. So we're going to click yes. And we're going to check this so it doesn't ask us every time we create a scope. And then we'll go back to proxy. And then to make the scope effective, we have to click in the filter bar. Just anywhere in the filter bar, click it once. And then click on show only in scope items. So make sure that's checked. And then now only the security.codepath.com website is showing up. And one more thing we're going to want to do is we want to set up our packets so that they come in, or they show up in descending order. So that way the most recent packet is on top. So if you just click up here in the upper left-hand column header, it'll now show the latest packet on top, packet number 14. Or request number 14, rather. And so now we're going to cover one of the Security Shepherd challenges and show off the different tools in Burp. So if we go back to Security Shepherd and we choose a challenge from week 1, I'm going to choose Insecure Direct Object Reference Challenge 1, or IDOR Challenge 1 for short. And I've clicked on it. It's loaded a bunch of stuff over here in Burp. And now I'm going to click on the different things. So whenever I see a web application and I see a button I can click, I want to figure out what that button's doing in the background in the web application. So I'm going to just click on all the names and click Show Profile. I'm not necessarily interested in the message that it's popping up on the front end. I want to really understand how it's working on the back end. So after I've clicked through all of them, I'm going to go back to Burp, and I'm just going to see if I can notice a pattern. So when I'm clicking on each of these requests, I can see the request that my browser sent to the server, and then I can see the response that the server sent back to the client, which is Firefox. And this is the same message that's over here. It's just that this is in raw HTML. You can also render the page if you want, but I don't recommend that. I recommend just using the raw tab for everything. Some people like to use the headers tab, and basically all that's doing is it's taking these things and it's putting them in a nice little spreadsheet form over here. But you can just leave it like this as well. And what I'm going to do is I'm going to use the first tool, which is the repeater tool that we want to talk about. So you can take any of these requests, since they're all essentially the same request with just a different parameter value. And the parameter is user ID something something. It's encoded in URL encoding. So if I wanted to decode what that actually was, I could highlight it and send to the decoder. So highlight, right click, and send to decoder. And now it pops up over here. And I'm going to decode it as URL encoding, because I can tell from the percent, 5B, %5D, that it's URL encoding. And that's URL encoding for square brackets. The reason some things are URL encoded is to protect it from having special meaning in the browser. Because normally a square bracket would mean something, same thing with an equal sign. So like an equal sign would be, so if I wanted to encode an equal sign in URL, it would look like this, because you'll see this one a lot too, %3D. So that's a little intro to the decoder tool. But let's go back to our proxy tab and let's send this to the repeater tool. So you can right click on a request and send to repeater. Notice too that there's also keyboard shortcuts for these two. So I'm going to send that to repeater. I'm going to go over here And now I can see the request file. I'm going to maximize this and pull this over so I can see it a little bit better. So these are all my headers right here. This is a post request. So you got your headers here, and you're going to have a blank line which separates the headers from the parameters, which is the user ID square brackets equals something. So this one equals 1. So let's send it over and see what it was. So this was Paul Bork's. So if I go back here and take a look at Paul Bork, this is what it looks like on the front end in the web browser. But this is what it looks like in the raw format. This is actually what the web browser is sending to the server. And this is what it's getting back. And then the web browser is rendering this. So if I wanted to see something that I'm not supposed to be able to see, then I would probably want to start with changing the parameter in this post request. But again, let's go back and look and see if we can see a pattern. So I see the first one I did was 1. That one was 3, 5, 7, 9. And then again, I did 1. So if I had to make an educated guess, what would it be? I don't want to give away the answer, but let's say we just tried 10 to start off with. This one says user not found. I wonder what the actual user is that we have to get. I'll let you decide that. We're going to go ahead and check out the intruder tool though. Because let's say we had to do a bunch of different numbers all at once, and we didn't want to do it tediously by typing the number each time. So if we had a bunch of different things we wanted to try and automate it, we would send it to the intruder then instead. So you can right click a request and send to intruder. And then in the intruder tab, target, just leave that alone, go to positions. And here we're going to set the payload positions. We're going to set where our inject point is, whatever we want to attack. So I'm going to go ahead and clear my position markers over here by clicking the clear all payload markers. And then I'm going to set the payload marker. So I'm going to highlight that number 9, and I'm going to click on add. So that's the point that I want to inject. That's the point that I want to try different things in. And then I'm going to go to payloads tab, and then I'm going to set the payload type. I could use a simple list where I would just enumerate every single thing by hand, or put in a text file or something. But there's actually a tool that's built into Burp. Since we're only dealing with numbers on this challenge so far anyway, I'm going to set the payload type to numbers, because there's a bunch of different ones in here, so don't have time to cover all of them, but numbers is one that you'll use quite a bit. So here we can set the range. The from is where it's going to start. So we could start at number 1. Even though we already know number 1, we can set it for demonstration purposes. And then the 2, we're going to set the range to go all the way to 20. At the most, on the free community edition of Burp, you'd only want to do about 100 at a time, because it'll really start to throttle you. It'll slow it down quite a bit. And then the step is, how many do you want to skip? Well, since we want every number between 1 and 20, then we're going to set the step as 1. If we wanted to skip every 2 numbers, we could set the step as 2. And then we're going to go ahead and start our attack by clicking Start Attack on the upper right. And it's going to give you a little warning because we're on the community edition. And it's good, like I said it before, it's going to throttle the attack. So it can only go so fast. So go ahead and click OK and acknowledge that. And then it's going to start. And we'll just let that run. Okay, so we've let the intruder run, and now we want to review the results. So we have all the different payloads here. As we can see, payload number 1 that we sent through. We know that this one was a valid one from before, and it was Paul Bork's message. The second one, user not found. Third was Will Bailey's message. Also notice over here the length column. This is very important because when you're doing a lot of these, you may not have the time to sit there and read every single response message, but you can just look at the length to see if anything's changed. And as you can see, these are changing quite a bit. Do note though that number 2, number 4, number 6, number 8, essentially all the even numbers are returning a 226, except for 8. 8 is returning a 225. I'm sorry, 225. I couldn't see. Yeah, all of them, all the even numbers are returning a 225 length. And that's essentially the length of the response. That's how many characters are in it. So I'm not really interested in those ones. But once you get into the double digits, then it becomes 226 when it's user not found. And that's because we've added an extra character. So it's gone from 225 to 226. So those ones we can essentially ignore because I don't care about the user not founds. I'm trying to find users that I'm not supposed to see, right? An insecure direct object reference. So ones that I would note is somewhere between 10 and 12 is the one you're going to want to probably look at. But I'm not going to show it for that. I'll let you go through it and do it yourself. So I can go ahead and close that out. But once you find the answer, your answer will be in the response. So that's that. Let's look at another challenge that gets a little bit more complicated. The next one. So reference challenge 2. And between the challenges, I like to also go back to my proxy history, HTTP history, and just right click on any of these and go to clear history when I'm done with each challenge. That way it's nice and clean and I can get a fresh look at things. And so once that's done, then I'm going to go back to Security Shepherd. I'm going to go to challenge 2 and I'm going to do the same thing I did for the last challenge. I'm going to click on show this profile on all of them. That way I can see if there's a pattern again. Okay, let's go back to Burp and take a look. So we've got these 5 requests. This was the first one, second one, third one, fourth one, fifth one that I clicked on. Because remember, the top one is the most recent one, the bottom one is the oldest one. But they look different now. It's no longer numbers, or is it? I noticed that they're all the same length, and there's some sort of hex number. Right? It's a hex number, and I can tell that because I only see the characters A through F and the digits 0 through 9. So that tells me it's a hex number, and the length is the same. And I bet you if I counted this up, I would see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 16 bytes is how long it is. So if you took 16 bytes and times that by 8, you got 128 bits, which is the exact length of an MD5 sum. And the way that I know that is by looking up. So if I thought it was an MD5, I could just Google MD5 or DuckDuckGo MD5 length and take a look. So yeah, it's 128 bits. That means each of these hex numbers, because if you know hexadecimal, it's 2 digits per number, or per byte, I should say. And there's 16 of them, so 16 times 8 is 128. So I know it's an MD5. So what can I do with that information? Well, now I need to use an outside tool to see if I can crack the MD5, because Burp will not allow you to crack an MD5. There is no tool available that just automatically can reverse a cryptographically secure hash, quote unquote. The only way that you can do that is by cracking them yourself or downloading somebody else's rainbow table, or to make your life easier, you can just use an outside resource. So I'm going to Google or DuckDuckGo how to how to crack a hash. So I'm just going to search for hash crack. And I'm going to go with crackstation.net. And I'm going to see if I can crack this hash there. So I'm going to copy that. When it's orange, that means it's highlighted. And And I'm going to say I'm not a robot. And I'm going to show all the buses. Select them all. I guess that's not it, but verify. And click on crack hashes. And bingo, we've got a result. So this is a known hash, and it is equivalent to the number 2. So we could also we can create hashes in burp. So if you wanted to create a hash, I could simply just type the number 2 and then go over to hash and scroll down all the way down to MD5. And then I'm going to encode it again as ASCII hex. And this is the same result I got. So that's what it is. It's a hash number 2. That's what is in these requests. Not that one, that's the old one. It's a hashed request. So my guess is that all of these are numbers. And so we could take all of these and put them through. So we can actually make this a smaller window here. And I'm going to go ahead and copy all of these over. So I've got that one already. I'm going to get this one. And then I'm going to say I'm not a robot again, and I'm going to crack them again. Voila, we've got all the results. So this time though, we have 2, 3, 5, 7, and 11. So to me, the pattern looks like it's going from 2 to 3. So that's 1, a skip of 1, then it's skipping 2, then it's skipping 3. I know it's skipping 2 again, and then it's skipping 4, it looks like. So maybe the answer is between 7 and 11, but it's got to be hashed. So let's go ahead and use burp intruder on this one to make our lives simpler. And we're going to go ahead and right click on one of the requests and send a intruder. And so we know that it's a number that's being hashed. Send it over. I believe I've already got it. So target, just leave that alone. Positions, we're going to set our positions. And we just want to set a position on this one. And our payload set is going to be numbers. And we're going to do 1 through 20. Or yes, 1 through 20 and a step of 1. And this one we're going to add payload processing. So the first rule we're going to do is we're going to do a hash. And then start the attack. So I see a lot of 256 lengths. That is probably ones that do not have a match. User not found. The 231 is found, which is Joe Sullivan's. Will Bailey, user not found. So as we go through them, this is what it's doing. So your answer is probably somewhere around here, around this area. So search through all the responses and you will find your result key. Thank you for watching. Happy hacking.